So, Unit 1-1 is classifying real numbers and putting the numbers into a number system. You have been exposed to this since 6th grade. We're just going to expand on it and get real good at it. So we classify things all the time. We classify you as a 7th grader. We classify you as an 8th grader. We classify you as Wellborn Middle. We classify you as College Station ISD. So if you are a 7th grader, you can be in Wellborn and you can be in College Station ISD. So we're going to label, and this entire gigantic thing is called the real number system, and it has components. Okay, first of all, we're going to start very in the center, and we're going to have natural numbers. And then going out, we're going to have whole numbers. And then we are going to have integers. And then we are going to have rational numbers. And then we are going to have irrational numbers. Okay, you will see it in circles, or you will see it in a huge gigantic box. Two ways you can do it, where this entire box is real. It is the real number system. Over here is irrational. Then you can have rational, but more specifically, you can have some integers, or a smaller group is the whole numbers, and a smaller group is the natural numbers. Okay, when you are looking at it in either diagram that you're looking for, if I am sitting right here, I'm also in this rational box also. This is a divider fence. Okay, if I put a dot right here, I'm actually in the whole, integer, and rational, but I'm not a natural number. Okay, we are going to go through some definitions so you can classify numbers. Okay, so if I do natural numbers, I'm going to just ask you, hey, or as a first grader, how did you start counting? And you would say 1, 2, 3, 4. So the set of natural numbers, they're the counting numbers. We begin with 1, and it goes infinitely. So these are 1, 2, 3, so on and so on. It's basically, I'll call them the first grade numbers. Those are the natural numbers. That's how you naturally started speaking. Whole numbers. I usually ask this question in class and say, how many tomatoes do you have right now? Logically, you wouldn't have any tomatoes sitting on your desk, so you would say 0. 0. So the first grader does not start counting with 0, they start with 1. The set of whole numbers numbers consists of all natural numbers and 0. So instead of starting at 1, 2, 3, we go 0, 1, 2, 3. And then we move into a bigger group. Does the number line have 0 to a lot? So if I'm doing a number line, does it 0, 1, 2, 3? Does it have anything over here? Absolutely it does. So some people are positive attitudes and some people have negative attitudes. So the set of integers consists of all whole numbers and their opposites. there are positive and negative numbers. So if I have whole numbers, I go 0, 1, 2, 3, and they're negatives. -1, -2, -3. Rational numbers. Do you always have a whole piece of pizza or a whole dollar? Oh, sorry, didn't scoot it down. Do you always have a whole pizza or whole dollar? No, you have partials. So the set of rational numbers consist of all integers and fractions, including terminating and repeating decimals. Okay, so numbers of integers and fractions. So we go, we had natural, we had whole, we have integers, and now the fractions, or the rational numbers, are all of these things in between the integers. So all of this space in here, that's my rational numbers. Okay, terminating decimals. Let's talk about terminating decimals. Terminating is 1/4. Sorry, let me write that again. 1/4, which is 0.25. That's a terminating decimal. But if I have 1/3, that is 0.33 repeating. Either way, either in fractional form or in decimal form, these are considered rational numbers. Irrational numbers. This is kind of a history lesson, but in Greece, a guy named Pythagoras said that the smart dudes in Greece forgot about a set of numbers. He kind of challenged the know-it-alls. He challenged the number system already discussed. Some people thought he was being irrational. The numbers that Pythagorean argued for are called irrational numbers. His argument did not repeat, and his argument never ended. Okay, the set of irrational numbers can never be written as fractions. Terminating or repeating. So what these guys will not repeat and not terminate. They have no pattern to them. So the best example is pi, and all non-perfect square roots. So square root of 16 is perfect, square root of 17 is not. That is an irrational number. This is not. So that's an irrational number. That's an example. Okay? Real numbers include all rational and irrational numbers. So think of it, consider the following numbers and discuss the number systems each belong to. If it is a decimal, it is a rational. If it is a fraction, it is a rational. Square root of 16 is actually simplified to 4, and so that is a natural number. That concludes the notes for 1-1.